what number is going to come out here? Is it going to be 3? Is that going to come out? So, like, if I did this, is that going to make it better? Is it going to print 3? Obviously, if I'm staring at you, probably it's not going to. This was a trick question, right? It was a trick question. This is what happens when you run it. So, we start out, smallest so far is -1. We come in with 9. Is 9 less than -1? No, it is not. So we skip. So the smallest we've seen so far is -1. We go back up. Is 41 less than -1? No, it is not. So we skip. So the smallest so far is -1. 12? No. 3 is not smaller than -1. 74 is not smaller than -1. 15 is not smaller than -1. So out we come, and the smallest we've seen so far is -1. No, it is not. So what's the flaw in our logic here? First off, the word smallest so far doesn't mean anything. This could be gorp or zap or x. So just changing the variable to say smallest so far is highly misleading. Okay? So at this point right at the screen to the one place that has the fallacy, the mistake in this code. If you pointed right here, you're correct. Right? So baked into that, when we were doing largest so far, was that these were positive numbers. And smallest so far, you know, starting -1, if they're positive numbers, well, smallest so far is already smallest than the smallest possible number. So what number might we put there to make this work better? Well, some of you might suggest that we would just say, oh, that'll be okay. I'll make that be 100, and it's going to work fine, right? And so 9 will tick, 41 will ignore, 12 will not work, 3 will tick, and it'll work. It'll work. That's fine. That would work if you made it 100. But then, what if there was 3-digit numbers in here? How would that work? Well, like, oh, let's make it 1,000. Yeah, that's it. No, let's make it 1,000,000. Or like more, right? What's a big enough number? As a matter of fact, that largest so far code that we did, if there were negative numbers and they're all negative, this is not going to work so well. Wait, largest so far, yeah. This is just not going to work very well, because what if they're all negative numbers? We just assumed they were positive numbers, and it worked just fine, didn't it? Whoops. Okay. So there's kind of a flaw. We were using this -1. There's a word for it. It's kind of like a flag value. It's not really the smallest number we've seen. It's like an indicator that we haven't seen any numbers. And we can't really pick a number for this. Frankly, either in the largest or the smallest. It's just not going to work. And so what are we going to do? Okay, so this is what we do. We have yet another type of variable. Remember I had Boolean, true and false, integer, floating point. There's a variable called none type. None. And it only has one constant in it. So Booleans have true and false. Integers have a whole bunch. And then floats have a whole bunch. And none types have one thing. None. We think of it as the absence of a value. The lack of a value. Okay? And so what we're going to do instead is in our smallest variable that we're going to do, we're going to say, you know what? Before this loop starts, the smallest number we've seen is nothing. We've seen no numbers whatsoever. And that's going to be our marker to indicate that we've seen no numbers. Okay? This is kind of like the found code, where we set found to be false and then later we set found to be true. But we're going to use smallest equals none. None is a variable, a value that we can distinctly detect different than numbers. Okay? So we can say, is the contents of smallest none? If smallest is none. Is like, it's more powerful than double equal sign. Means, is it exactly the same as? And so if we are asking, is smallest none, that's only true if we've got a none in there. If we put 17 in, smallest is not none. So this is how it works. You start with smallest equals none, and then in the code we have a little bit more intelligence. If smallest is none, this means that it's the first time. If the smallest is none, smallest is value. So 9 is coming in here. And so if the smallest that we've seen so far is empty, we have seen nothing, then we'll grab the first one as the smallest one. So our 9 becomes the smallest one. And so that's how we print out the smallest so far is 9. We just saw 9. Then we come up. The second time through this loop, this is going to always be false from now on, because smallest is a number, and number is not none. Okay, so we have this flag value that's none just for the first time through the loop. So that's false, so it's going to run here. Elif value is less than the smallest, which is 41. Is 41 less than 9 in this case? And the answer is no, it is not. So it stays 9. Then 12. 3 works, so 3 causes this code to run, so we grab it. So 3 is it. Then we go through 74 and 15. It runs 2 more times. And then when we're all done, we get 3. This is a flag value that we're checking. And through the loop, it'll only be smallest will only be none the first time through the loop. But after that, we'll just ignore this little part. This is another way to think about this is priming us. This is getting started. Okay, and this technique is a good way to do the largest and the smallest, to use this none, and then have a little bit of code that triggers the first time through the loop to get your sort of loop carried variable set up. Okay, so the is and is not operator, they're both operators. They're like is and is not are like less than or equal to or not equal to. They don't hurt their operands, and they return you a true or a false. Okay, so is none and is not is also a logical operator. And there are other times we use it. You shouldn't use is when you should be using double equals. Usually you're using them for true, false, or none. So that we don't overuse is, because is a really, really strong equality. So it's a stronger equality than double equals to. So the double equals is mathematically equal to with potential conversion. But is a stronger thing. And is not is the opposite of is. Okay, so in this chapter we've talked about some definite loops, some indefinite loops, break to get out of loops, continue to pop back up. Continue works in for loops as well as while loops. Iteration variables, how with while loops you construct them yourself, and in for loops for constructs them for you, and things like largest, smallest, counting, average, etc., etc., etc. So we looked at some loop idioms where you do something at the beginning, do something in the middle, and then you get the payoff at the end.